In 1989, Tim Berners-Lee invented the HTML that changed the world. But HTML wouldn't really do much if we couldn't fetch documents from around the world and different computers. For that to happen, Tim built the Hypertext Transfer Protocol, or HTTP for short. Now, remember these arrows from the diagrams that we've had? We told you that these arrows were simply the connected wires and cables that connected the World Wide Web. This, right? You remember the diagram. But you see, these are just wires. There are no instructions on how to do things. For that, you need something called a protocol. Think of it as a standard that everyone follows. If everyone agrees, then the protocol works and can be used by everyone. HTTP that I have here is a protocol which allows the fetching of resources such as HTML documents. I mean, it's in the name, right? Hypertext Transfer Protocol. Now, with the use of HTML and HTTP, we now have the World Wide Web. We can grab HTML files and receive them. If we go to google.com/about, we go to the About HTML page, we grab it and receive it. So HTTP is the protocol or the rules that we use over the wires. It is the foundation of any data exchange on the web. And it paved the way for something called a client-server protocol, which means requests are initiated by the recipient, which in our case is the web browser. So they send out a request using HTTP. The server now understands what the web browser is saying because it's speaking in HTTP. And the server can now respond with HTML, and the browser understands it because it's speaking through HTTP once again. So you should think of HTTP as a common language that a client and a server can use to communicate. They're simply saying, hey, can you give me this document? And the server can say, yep, no problem, here it is. And up until this point, we haven't really spoken to a server in our app, have we? We build the front-end applications or the client-facing applications using HTML, CSS, JavaScript, and React. But we lived in our own world. No communications with another computer. HTTP allows us now to communicate with servers, with the outside world. So let's go over the terminology one more time. Clients and servers can communicate by exchanging individual messages. The messages sent by the client, usually a web browser, are called requests, and the messages sent by the server are usually called responses. So if HTTP is the language that allows us to communicate between these two, teach me some of the words, right? I mean, that's a good question. And lucky for you, HTTP is quite easy to learn because you only have a few words. And I'm going to show you what they are right now. You have get, you have post, you have put, and finally you have delete. And now you're thinking, that's it? And yeah, HTTP is beautiful because it's just simple. You don't need to overcomplicate things. You learn these 4 words and these languages, and you can build the app of your dreams. So let's go through it one by one. Get means, well, I want to get an HTML file. So you ask to get something, and the server responds with that request. A post says, I want to post something. So that is, I'm going to send over some data to Google servers, and I want you to post. I want you to add it to your servers or your database. Put is, I'm going to send you some data, and I want you to update some data that already exists in Google servers and just update it with this new information. And then delete means, well, delete a piece of data on the backend, on the servers or on the database. So if we use Twitter as an example, get will be to receive the Twitter feed with all the tweets from today. Post would be if you created a new user and you want to add that user to the Twitter servers. Put would be if you made a tweet but you want to make a change or an edit, so you edit that tweet. And delete will mean, well, you either delete your user account or delete a tweet. And don't worry, we're going to use these when we get to the backend section and we build our final project. Now, over the years, HTTP was extended to not only worry about text, not only fetch hypertext documents like HTML, but also images and videos and post content to servers like with HTML form results. And HTTP can also be used to fetch part of documents to update web pages on demand, which is called AJAX. And we have a video coming up talking about this. But the main idea still stands. Using these 4 verbs we just learned, we can now communicate with servers. All right, so we know that this arrow over here at the top uses HTTP to make requests using one of these 4 verbs. Okay, so I think you get the request part. Now, what does the server respond with? What about response here? The server sends you 2 main things. One is an HTTP message that is something that you've definitely seen before. And I'll link to this W3 Schools resources. A 200 message means successful. You probably have seen 200 OK before. You might have seen 404 messages, which means not found. If you enter a URL that doesn't exist, you'll get a 404. And maybe sometimes you'll get a 500 error message that is, well, there's something wrong with the server. So this is just a number code that comes with every response that tells you the response of the server. So that's the first one. The second one is usually some sort of data, like HTML. And so far, that's what we've been doing, HTML. But in the next videos, I'll show you that it can send other things other than just simple HTML. So let's add to this diagram now. We want to say that this also has a status code, and we'll say 200 for now, that everything was fine. And in the response, we give the status code plus the new HTML file. All right, let's actually demonstrate this online and see how you can watch this action take place. I have over here a great website called example.com, and it's a simple website. You can go visit it right now. But the cool part about it is if you open up your developer console, up to this point, we've looked at the Elements tab and then the Console tab. I want to show you the Network tab that we have here. Now, the Network tab, you might have to click on some of these icons, and you'll see that different things will pop up. Make sure that the filter is gone. Everything is unclicked. And now at example.com, while this is open, just simply refresh. And look at that. I'm going to click on this icon, which makes it a little bit bigger. This is a plugin, so don't worry about this JavaScript. But the top thing, it says example.com, status 200 OK, and type document. And it even tells me the size, the time that it took to get this, which is 53 milliseconds. That's pretty fast. So that means the server responded with 200. If I click on this, I get a whole bunch of things that we don't really need to worry about, but a few things. Request URL, this is what we requested. We get a status code of 200 from the server. And if we click on the response, there's the response message. We received the HTML document from the server. If we go back to headers, we also see that our request method was a get. We did a get request. Let's close this and refresh again. I now get a 304 status. A 304, if we look over here, means not modified. Indicates the request page has not been modified since the last requested. Because I've already requested this now, Google is smart enough to say, oh, I'm not going to worry about the server and requesting the same thing over and over. I already have it memorized, so here it is. Very cool. So network tab is really, really useful for that. All right, so you can go ahead and play with example.com and see for yourself how HTTP works. And by the way, yes, this HTTP that you see here, that's what it means. When you do an HTTP request, it says, hey, do HTTP. We're using the World Wide Web and go request this from the server. Very cool. And if you're wondering about the S, don't worry. I'll let you know at the end of this video what that means as well. All right, now what if I want to send data? If we go back to our diagram, I'm just doing a GET request, but what if I want to actually send some information to the server other than some URL saying I want this information? Well, there's two ways that you can do it. One is something called query string, and then the second one is through the body of the request. So I'm going to show you how both of those work. I have over here the form that we created in our first advanced HTML section when we only knew HTML. Let's open this file up. I have it over here. If I double click, you remember this, don't you? We've come a long, long way. In this form, if you remember, we had a form method get. And now you might understand what this get means. It's saying, with this form, I want you to do a get request. Let's see what happens when I click register while opening the network tab. I'm going to click register. All right, so we have this request. We see that we have made a request and it has created these things called query strings, the first way of sending data to the server. With a GET request, if you want to send information through a form, it adds it to the URL using this question mark, which says, hey, I'm about to send you some query strings, and it's going to have a key and a value. In this case, first name, last name, everything's empty, so there's no information, but otherwise it'll say first name equals Andre. If I click on this, we see that there's query string parameters that we've sent. We have first name, last name, email, password, and birthday, which is blank. But if we scroll down, in cars, default is Volvo, so that we have cars Volvo. So this information now is sent to the server. That's query string parameters using GET. And we did mention one thing though. We see that we have password in here. That's not very secure, is it? If I went back to the form and I type in secret and I click register again, well, now I have my password out in the open, sent over the wire, and I even have it up here in my URL bar. All right, we'll get back to that. So that is one way. The second way is through the body of the request. Let me show you how that works. The way we send information to the body is we use a post request. And this is something that you'll more often see than a GET request, is that we want to add some form data to the server. So we want to post something. If I change this over here, I'm going to save this. And let's open up a new tab with the new saved data. This one is a post form. If I open it up here and I type in password secret and I click on register, I get register.html, but no query strings. If I click on this, I see that now instead of query strings, it's form data. And it even says content type, application, XWW form URL encoded. And this is just an HTML way of saying that this is a form and this is the body, but not displaying here. So now the server can access it not from the query params. And don't worry, I'll show you how servers do that when we get to the backend section. Instead of accessing it through the query params, I can now access it through the form data. So let's go back to the diagram. We now understand that we can do HTTP requests using get, post, put, delete. I can use query strings, which are at the top of the URL, to send the data, or the body of the request. And then the server responds with a status code based on how my request was, and it returns that with a response. But the one issue we saw was that, well, the password was visible in both cases, wasn't it? And what if I have a scary looking person over here? There you go. What if we had a person who was watching our communication, our HTTP requests, and monitoring it? If I used query strings to put my password in there, well, he can just look over my shoulders and see, oh, Andre's password is secret. I can now log into his Google account. Or if I use the body way of sending data, well, he can find a way to get this request to come over to him first and just look at the form data and see that my password is secret. That's not very good, is it? Well, one solution to this was the idea of HTTPS. Now, HTTPS means Hypertext Transfer Protocol Secure. And you can see over here that W3C uses the secure version of HTTPS. The communication between the browser and the websites are now encrypted. And what does that mean? Encrypted just means that it's jumbled up, so only the client and the server know the secret pass or secret key to read the message. And this S part, the secret, uses a technology called Transport Layer Security, or its predecessor, Secure Sockets Layer, or TLS and SSL for short. So now, even with HTTPS, if the attacker, or what we call a man in the middle, the person who's just monitoring our requests, even if they get our password, it's going to be just complete gibberish. It's going to have something similar to this, and well, that's not our password, so it's going to be meaningless. It avoids that attack. This is just a tip as a developer that you should tell all your friends. If you're ever sending sensitive information, maybe logging into a bank account, make sure that there's HTTPS out there. If there's no HTTPS when you're sending maybe your login with your password, well, that's not secure. All right, let's review. Your web browser is a HTTP client sending requests to the server machines. When the browser user enters file requests by either opening a file or typing a URL or clicking on a hypertext link, an anchor tag, the browser builds an HTTP request and sends it to communicate with the server. Now the server can get information back to us. The earliest version, we could use URL parameters such as google.com/about and just specifically get HTML. That was it. Then came the form. So we can now actually send more data other than just the URL saying we want to go to this HTML file. Now we can use get or post to send data, either through a body or a query string. And a server can take action based on that data and return a new page. And this is the foundation of the web and how the World Wide Web we have now was made possible through client-server communication. In the next few videos, we're going to learn even more to really understand this power. I'll see you in the next one. Bye-bye. Welcome back. There's one missing piece with the diagram we created in the previous video on HTTP. We talked about URL parameters such as the google.com/about and query string parameters we can do with get. But what about the data when we post something? Can we post anything? Well, not really. When exchanging data between a browser and a server, the data can only be text. So we can't just send a JavaScript object such as a user with first name John and last name Doe. One, because HTTP won't understand it. But also, if we were sending this data to Google servers, well, unlike the front end, the web browser where HTML, CSS, and JavaScript is a standard, when I send a user object to the server, a server can use any type of language like Python, Go, PHP. If we send them a JavaScript type, like an object, they will really be confused because they would have no idea what it is. That's not really their language. Text, on the other hand, can be understood by all. So we need a way to have a standard way to send data over the wires and receive it. That is what JSON is, and what we're going to talk about in this video. JSON stands for JavaScript Object Notation. It's a syntax for storing and exchanging data, and it's text written with JavaScript Object Notation. Let's look at the second point here. JSON is a syntax for storing and exchanging data. It's used to send data between machines. Is it the only way? No. There's also XML. Both XML and JSON can be used to receive data from a web server. And you can see the differences between the two. These are the same data, just first names and last names of employees. And XML uses this HTML-like syntax, while JSON uses, well, an object, JavaScript object-like syntax. But the standard is now more towards JSON, because when you're writing front-end code in JavaScript, getting a JSON data back makes it easier to load that data into an object tree because it's so similar to a JavaScript object than an XML. And JSON format is a more succinct way which saves bandwidth and improves response times when sending messages back and forth between client and server. And XML is just not very efficient. So JSON now is more of a standard. You'll still see XML, but it is outdated, so we won't be talking about it in this video. But they both are used to transfer data between two machines that might not speak the same language. JSON, however, although it looks similar to JavaScript, it is a little bit different. It has these double quotes for even properties. Everything has to be a string and wrapped around double quotes. And, well, it looks like it's a object syntax. But JSON can be read by any language. If Google servers was running a different language, they'll understand JSON. They'll be able to modify that JSON, which is just text, into their own version. So now we can convert this into a JSON object, send it over HTTP, and then the Google servers, or whatever it is, will change it to their own language, understand it, and then send a response again. Let's say, for example, it was returning the user has money, $345. Well, it will then modify this to JSON, send it over the wire, and then the web browser will change it from JSON to JavaScript. But how can we do that? Luckily for us, JavaScript comes with its own JSON function. We have JSON parse and JSON stringify. With JSON parse, if we had JSON, again, this form, we simply wrap it as the parameter of parse, and it will return a object. In the opposite way, with stringify, we can give it an object, such as the one we just created, and it will return JSON. So this myJSON variable can now be put into the HTTP request to send it over the wire. Or the server can respond with myJSON. So let's review. JSON is text, and we can convert any JavaScript object into JSON and send JSON to the server. We can also convert any JSON received from the server into JavaScript objects. This way we can work with data as JavaScript objects with no complicated translation. And this text can be used as a data format for any programming language. So let's go through the flow one more time now with this complete. User object. Before I send it with HTTP, I will do JSON.stringify user. So now it's converted into a JSON string. And this JSON string will be sent over HTTP to the Google servers. It is then going to say JSON parse this user so it understands it. Let's say it was running JavaScript or Node. Now it'll understand the user. It'll say, oh, he wants the money amount for this user. So now it gets money 345 from the account. It stringifies it, the money variable, sends it with a status code of 200. And now the web browser can parse this string that it received and see that, oh yeah, I have a variable money of $345. And don't worry, when we get to the backend section, in a few videos, we are going to show you exactly how to do this in code, how to make HTTP requests, use JSON, use get, post, put, delete methods. And I'm going to show you how to do that in our final project as well. But now this diagram, although a little bit messy, should make a little bit more sense. And you should understand now how things are working. In the next video, I'm going to introduce you to something that changed web browsing in 2006. I'll see you in that one. Bye-bye. Welcome back. In the previous videos, we learned about HTTP and JSON. We learned that we can send requests and get responses. But there's one issue. Up until now, every time we need to communicate with the server, we make that request. Then the browser, when it receives the response, does a page refresh. Originally, page loading on the web was simple. You'd send a request for a website to a server, and as long as nothing went wrong, the assets would be downloaded by the web page and displayed on your computer. The trouble with this model is that whenever you want to update any parts of the page, for example, display a new set of products, like on Amazon, well, you'll have to load the entire program again. Even the outline, even the navigation bar at the top, everything had to get reloaded, a complete page refresh. This is extremely wasteful and results in a poor user experience, especially as pages get larger and more complex. You can think of it on the Udemy website. If we go to Udemy, well, if I click on, let's say, marketing, the top bar will remain. Do you see that? It's a nice user experience. I can click on tabs and I won't get a complete page refresh. It loads data automatically on the page. Now, this issue that we had here led to creation of technologies that allow web pages to request small chunks of data, such as HTML, XML, plain text, JSON, and display them only when needed, helping to solve this refresh problem. And the technology was called AJAX. It allowed you to read from a web server after the page has loaded and update a web page without reloading the page. And finally, send data in the background while the user is interacting with the website. It was actually pioneered by Google in 2006 and now is what we expect of websites. And any web app you see online uses AJAX now. You see, Google had this big problem. When we're searching something, well, you would initially type in Apple and it would do a complete page refresh. But now with this, I can maintain the top bar and have this loaded. I can even have suggestions brought up from the server. And this is all a response from the server saying these are some of the suggestions based on Apple Store. So it was a big problem for Google and they were able to solve it with AJAX. But now we all have this ability. So how are we able to do this? What is AJAX? AJAX is just a technology, a method of combining pieces together to achieve this. And it was achieved using a tool that browsers built, and it was called XML HTTP request. It looked something like this. You created a new XML HTTP request object. As you can see, it looks a little bit tough. You make a request, you make a GET request at this URL. You say onload when it loads. If the status, the response, is greater than 200 or less than 400, it's a success. We're going to parse the response text. Remember, because we're receiving a string from the server. If it's not a success, well, we can return an error. And we then send our request and also listen for any errors. It looks pretty tough, but it is things that we've gone over. But don't worry, we actually don't do this anymore. This was the old way of doing it when AJAX was first introduced. jQuery came along and said, well, this is kind of tough to do every time. We'll make it easy for you by just doing this. And that was another part of the reason that jQuery was popular. We can just do AJAX requests doing this method. But now there's actually an even nicer, newer way that we've used actually when we build our React app, and it's supported by the browsers. And that is called fetch. As you remember, it was fetch at a URL, and then we did this .then response, and we received a response. Now, this is a really good thing because page updates are a lot quicker and you don't have to wait for the page to refresh, meaning that the site feels faster and more responsive. Also, less data is downloaded on each update, meaning less wasted bandwidth. And this is a major, major issue, especially on mobile devices where internet connection might not be as good. AJAX allows web pages, and by extension, web applications, to change content dynamically. And it is everywhere. It is something that is just very nice. It looks intimidating, but it's just a matter of doing this, fetch, that does HTTP for you. And all you do is say, if you want to do a GET, a POST, and add some JSON data to that request. So let's review again what happens with AJAX. An event occurs on a web page, such as logging in, and I click sign in. XML HTTP request object, again, something that web browsers have implemented, is created, and that's created using JavaScript. XML HTTP request object sends a request to the web server. The server processes the request, and then the server sends a response back to the web page. The response is read by JavaScript, and the user is able to log in. At the same time, only updating a small portion of the window. That is what a single page application is. And it's a word that you've probably heard before, and it's a trend in how to make web apps, where you load a base, an almost empty page, and build the content on the fly based on the data fetched from the server. Let's go back to Udemy. When I click on a course, let's do public relations, you see that this is loading one at a time. I had the top bar loaded, then I had a pause, and then the rest loaded. If I click on Explore Course, you see again that top bar loaded, other parts of the web slowly dynamically load. And again, if I go back to photography, for example, again, parts of the web page load dynamically. And that's the beauty. These applications nearly never do a full reload. They destroy the previous content, all or part of it, and rebuild it based on new data, new page. And this might sound familiar to you. Do you remember how we built our RoboFriends app? We fetched this URL that gave us users. So now that we understand these concepts, let's go line by line and see what happens. I used fetch. Based on what I said, fetch should be part of the window object, right? Let's check. If I open up the console and I do window.fetch, yeah, fetch is a function that we can use. And this URL, if you remember, returns for us, what is that? Yeah, a JSON object. And this JSON object, fetch allows us to do something called response.json. Well, let's just do this for now and see what happens. I'm going to copy and paste this. I'm going to open up the console. And I'm going to open up a new tab to show you that you can do this from anywhere. If I copy and paste this fetch, I get something called a promise. And this is something in JavaScript that you'll get used to. Promise is saying, hey, I'm making a request somewhere over the internet, and I promise to let you know when I have this value returned. So the way you access promises, so you have this, once this is returned, give me the value, you do .then, and it gives you the response. If I add to my previous request .then, and I do response console.log response, look at that. I get a response. Status 200. We remember this. Okay, that's good. And we also get this body, but it says readable stream. And fetch, we learned about JSON.parse to parse JSON. But fetch actually comes with its own method called, JSON. So on this response, if we do JSON, it will actually convert it for us. Let's see. If I go back to that request again, I get a response. If instead of console logging, I say response.json, in that case, I get a promise again. So that means we need to do .then to receive whenever this returns the promise, which is the value. So again, I go up and do .then. And in this case, let's see what data we receive. We get data, and we'll console.log data. If I press enter, look at that. We receive our users, the same users that were here. So you see now that we simply use the fetch API, which allows us to do an AJAX call after the component mounted. So once our RoboFriends app was loaded, we made an AJAX request using the fetch API. We got a response, which was a promise. So we had to do .then. And this response, and this is just standard that anytime you do fetch, you'll just remember doing .json. I converted this into something that, we can use in JavaScript. And because this returned a promise, we did .then, we got the users, and now we have the users object. And we never had to refresh the page. And by the way, if you want this JSON, whenever you're accessing it to look prettier and be a little bit more readable, I am using a Chrome extension called JSON View. It's free. You just add it to Chrome. It automatically does it for you. I highly recommend it. Okay, let's go back to this. This should make sense now. We now have the ability to dynamically load our web pages, make single page applications using AJAX. And AJAX is a combination of tools of using the Fetch API, using HTTP, using JSON to communicate with servers. And now we have a complete picture of our front end. Our front end can have HTML, CSS, JavaScript, React. We can use AJAX to communicate with servers. And we use JSON data to send data over the wire. I'm really excited for the next couple of videos. So I'll see you in that one. Bye-bye. API, or Application Programming Interface, is a messenger that takes a request and tells the system what to do. Huh? That doesn't mean much, does it? In this video, I'm going to explain to you exactly what an API is without all this confusing wording. I have over here a Skyscanner. If you've never used it, it's an aggregator website. I look for a flight from LA to New York, and it searches all the websites, all the airlines for the best deals for me. Now, how was it able to do that? It found all these flights from different websites, but Skyscanner doesn't really have this information. I mean, this information is somewhere in the database of each individual airline. But as an airline, you're interested in having this data on Skyscanner because people like myself that want to book a flight might not know to go to AmericanAirlines.com. So by having their information listed on a website like this, well, now they can increase their revenue. So how is Skyscanner able to do this without having this information themselves? Well, that's where APIs come in. If you remember, APIs is what allows strangers to speak to each other so that we aren't in a closed system. We can share data and work with each other. And APIs is what allows machines, computers, to communicate. This might sound familiar. It's kind of like how we had web browsers speaking with servers, right? Well, yeah, because API is a broad topic. It applies to the way machines communicate. If I open up my console here, well, I always mention that there's a window object, and the window object has fetch. And fetch is an API. It is given by the browser to use so that I can communicate with this machine, that the console can communicate with the browser. In the same way, although Skyscanner doesn't have access to the databases of American Airlines and Alaska Airlines, all the other airlines use APIs or give access to this information through APIs so that websites like Skyscanner can have the information as well and list it on their websites. The best way to think about it is kind of like a waiter. You're sitting at a table, about to order, and the waiter is the messenger that tells the kitchen what to do. The kitchen is providing the waiter, the restaurant, right? The restaurant is saying, hey, waiter, these are the menu items. Please go ask the customer what he or she wants and let us know so that we can prepare it. And this might sound similar to this, right? We're asking another machine for something using, let's say, a waiter, and this machine gives us a response if we talk to it in a certain way that it expects. And yeah, a server has APIs, ways that you can communicate with it, such as doing users/about. In the same way, We also have our code previously from when we built RoboFriends. React, which is a library built by Facebook, exposes an API, a way to communicate with the React package by doing React component and using JSX. They tell us how to communicate with it, and we're able to communicate with it. Let's work on this a little bit more. What about this? Is this an API? It's the back of a TV. Yeah, it's an API. A TV works in its own way, but it gives you access to a couple of things, such as an HDMI cable, so you can plug into it and communicate with it, such as displaying your laptop into the TV. And we've been using APIs in the RoboFriends demonstration as well. We already talked about React, but you remember the JSON placeholder, the users that we got? Well, if I go to their website, we see that it's a fake online REST API for testing and prototyping. It's an API, so it must be giving us information about something that it has. If we go down, we see that it has resources, and the API tells us we can access them using these methods. So by just writing comments here, I should be able to get 500 comments. And there you go. I get a response in JSON. And even with RoboHash, remember how we were able to get images of robots from this, robohash.org? That's an API. We can say robohash whatever, and because they've said that the way to access this API is to just type in random numbers after robohash.org, we're able to access it. And people build these APIs usually for business reasons, such as airline companies, right? And they have the incentive to comply to industry standards, such as having JSON responses. And that way it makes it easier for a developer like myself to grab bits and pieces from different places. For example, here I have the GitHub API. You can read up on it, but I can access information from GitHub. So I'm accessing the GitHub repo of Facebook, and it tells me how many followers it has, what bio it has. If I go to Apple, I can get the Apple username as well. And you can see that it's in JSON format because that is the standard. If we want to build something with GitHub, well, we can just send a request to this, get this data, and create our website based on this data. But it's not only JSON. If you remember, there's XML as well. This is a sample API that shows us a breakfast menu. And here we can request this data through HTTP and we get breakfast menu. So as you can see, APIs are not just websites. A TV's inputs and outputs, that's an API. An NPM package can be an API. Like I've said before, it's a way that people communicate or machines communicate and share information. Without it, we really wouldn't have what we have now with the World Wide Web. But how is this useful to us? Well, first off, we can build something like this quite easily. We can actually search API JetBlue, API American Airlines, and they'll have information on how we can access this data so we can build our own thing. This website, all it's doing is making an HTTP request to something like here, and then grabbing this data and just adding some CSS to it to make it look nice. And there are a ton of APIs online. You can search them, you can read up on them. Big companies like Facebook have APIs, Google has APIs, and you might know Google Maps. Anytime you see Google Maps on a website, it's using the Google API. We also have silly APIs like this one of my favorites, it's the Star Wars API. It shows you over here, if I do people 2, I get C3PO. If I do people 3, I get R2D2. I can also do planets. This is a free, nice to use API. So you can build a sample app using the Star Wars API, and all you need to do is just fetch this resource, get the JSON, convert it to a JavaScript object, and then style it and use it in your app whichever way you want. There's also some really important APIs that, if you're building serious websites, are really useful. This is the Stripe API. If you want to incorporate payments into your website, well, this shows you exactly what to do, and you can add to your server in whichever language you want. In our case, we're interested in Node, and it tells you how you can add Stripe as a payment method on your server. It sounds scary, but it's all documented in here. It's step-by-step instructions of how to do it. Another one that I really like is the Twilio API. And Twilio allows sending of messages on phones. So using something simple like this, you can see there's not much to it other than using this client.messages.create that they provide. And we just say what we want the body of the text to be, to which number, from which number. If we want to include maybe a heart, then we can add that as well. And let's say when a user signs up for a service, well, we can send them a message by saying, hey, we've created a new user. They've provided us their phone number. Send them a text message. Now, you might be thinking, this is almost too good to be true. You have so much power now. You can just research APIs, and all the major websites have APIs, data that they give to you. Well, things like RoboHash and Star Wars API, they're silly and they're fun, and there's no real cost to them. But when you start building real applications and companies like Stripe and Twilio, where there's some real engineering effort behind creating these, well, they charge a service. And that's when you use something like an API key. And an API key looks like gibberish. It is a key, a private key, so that every time you access their API, they know that it's you. And because, let's say you have a plan for making 1,000 requests, they charge you because they can recognize you, saying that, oh, this is Andre's key. He's the one making the request from a server, and we're going to charge him for it. And don't worry, in our final project, we're going to be using a really, really cool machine learning API. And we're going to generate our API key and actually use it. Luckily for us, though, it's free. So it's going to be a lot of fun. But from this video, I want you to remember this. A server somewhere in the world for a company provides an API. In order for other people to use it, they usually tell you how to use it. And they have documentation on how to use it. But most of them comply with a standard like JSON to make it easier for developers like us to use. And at the end of the day, an API is a tool used for data communication. It's how a program, a software, or anything running code allows others to communicate with it. And it opens up a big possibility of making websites that do more than just list robots. You can now, with the same principles, build websites that incorporate different APIs to have the functionality of something like Skyscanner. I'll see you in the next one. Bye-bye.